So what I'm going to do now is just turn it over to Hector, but Hector's going to talk a little bit about some of the work that they've done with the U.S. Census. And most of us know the U.S. Census from the every 10 years we fill out our census forms, but Census does a lot more than that. The U.S. Census is responsible for creating the economic indicators that really give insights into what's happening across different economic factors or sectors within our country. And they help determine where over $675 billion worth of federal funding is going to go, as far as what states it's going to go to, local communities and businesses. So to keep our national U.S. economic engine strong. But for many years, a lot of the work that went into generating those economic indicators, things like construction starts and getting a view of that, was a manual process. A manual process where forms were filled out, they were sent in, geo coordinates were captured, and then people continue to fill out those forms, and all that data had to be manually captured. Cumbersome process, manual process, expensive process. But today we're going to ask Hector from Reveal Global Consulting, one of our Alteryx partners, to talk a little bit about the U.S. Census, talk about how they utilized Alteryx to help capture information from satellite imagery, and how they were able to automate that process and really help the U.S. Census Bureau generate those same level of insights around economic indicators around construction starts, but do that in a more automated process. So Hector, I'm going to turn it over to you now.
Thank you, Andrew. Thank you so much. Good afternoon, everyone. It's a pleasure to be here with you guys today. To pick up from what Andrew just described from the U.S. Census case, as you know, and Andrew mentioned, Census measures the health of the nation's economy. It's one of its indicators is the GDP. It measures the output that the country is producing, and a huge part of it is the construction section. And on this particular use case, we'll focus today. We'll actually describe how we're helping Census by using Alteryx, by using automatic process, machine learning, and satellite images in order to help them speed up and scale up and create a innovative process that actually is closer to the ground truth and helps them validate and speed up the whole process in terms of creating and then reporting these indicators. So as we mentioned, right, if you think about the scale of this data, Census actually collects data from local governments, county, state, federal. There are approximately 20,000 counties and unincorporated areas that are required to report on single-family home construction activity every month. So that's a massive amount of data. And on this particular use case that we helped them transform this process, we were focused on construction activity related to construction starts, construction that is in progress, and then completions. So the construction stage of these projects. So our team was tasked to help them innovate this process, right? This solution actually integrated machine learning, satellite images, and automated process by actually putting everything in one process or one workflow, and actually we leverage the power of Alteryx to do that. And the reason why this is powerful is because, as Andrew mentioned, it's a mix of data analysts, citizen data scientists, actual experts, data scientists, and statisticians that can actually collaborate on one place. And with that collaboration, you get faster development times, right? So what Reveal has done to help Census is create a solution that automatically identifies and classifies U.S. construction activity by applying machine learning techniques to satellite imagery, covering a geographic area of about 11 million football fields. So it's a big, big area in the United States, and we do this every month while maintaining highly accurate results and fast processing times. So as you can see, with this solution, we'll help Census translate and transform their process slowly, gradually into a completely automated approach to this more than 100-year-old approach from the survey collection that they had. So Andrew, if you can please go to the next slide. What I'll show you guys here is a demo of our Alteryx solution that fits in all the little pieces of this process and puts it in one place. That's the power of this, where in other solutions you might have separate environments for the different stages of your process. with this solution on Alteryx, we're able to leverage and pull everything together in one place. So just from this image you guys are seeing here, it's an overview of our architecture from the workflow. You start all the way on the left by collecting. So you have the data collection, which is automated as well. Then you go into the middle part of the workflow, which will show into the pre-processing. So data cleaning, data blending, data processing, pre-processing. And then with that output, you transition into the analytics, right? So there's the cropping and prepping those images for the analysis and classifications. And then lastly, we'll show how we report those results and how there are many ways you can do that actually. So with further ado, I'll actually share my screen, Andrew. I'll turn my video off as well so we can get some more speed. And here we go. Give me a thumbs up if you can see it, Andrew. Workflow's up. Perfect, thank you. So what you see here, guys, is, and I'm gonna minimize the Zoom screen. On this zoomed out version of the workflow, what you're able to see is, as I mentioned, there are different containers on our solution. And these containers are all connected. So by workflow, as the name says, you flow from one side to the other. And from, in this case, we flow from data collection to the data pre-processing and the data analytics. And lastly, data reporting. Data here for us, as Andrew mentioned in the beginning, it's a combination of structured and unstructured data. So we have flat files, we have combination of different, structured and unstructured data, text files, Excel sheets, and the more interesting, which are the images. So when you think of an image, it's an unstructured format. By applying other data layers and the pre-processing method in the middle, you can actually convert it into meaningful data that it can become structured. And then with that structured data, then you run your analysis. So what I'll show now is actually how we run this and what are the outputs of each of these stages. Again, the goal of this workflow is that, as you see here in the very beginning, a company or an agency, a government agency, or an individual can select a location. In this case here, we'll focus on Houston, Texas, but you can select any location. Let's say in the US, any location and a specific date or range of dates, right? Or a frequency where we're going to be collecting these images. And our workflow automates the process of collecting these images and then prepping it and doing the whole analysis you see here. So our initial inputs are the location and the date. This case here, as I mentioned, we have Houston, Texas, and we're already showing you guys the image. This is a preview of the image. We work with all sorts of resolutions. In this use case, we're working with high resolution, 50 centimeter high resolution satellite imagery. And the goal, again, is once you have this image, after selecting your location and date, we're going to do a lot of analysis throughout the workflow. And by the end of it, we'll actually classify each property inside of this image by using a machine learning model that we've already trained based on thousands of images. It's going to be on this container here. And we're able to call it via an API call. So just to wrap, the summary of this workflow is that we're automatically identifying and classifying construction, and then which stage each of those construction projects are reflecting in those images. So I'll actually start zooming in and going into each of the steps. As you see here with Alteryx, it's very interactive. I think that's one of the things that our team loves about Alteryx. It's almost like an art, right? You combine the technicalities with a little bit of an art where you visualize it. You can place your containers and tools in specific places. You can change your icons. You can select, you can customize everything on your workflow. And this helps actually because when you have a full team, a team is consisted of different roles. You have your more expert data scientists, senior data scientists, but you also have your business leaders. You have your data analysts. And with a workflow in this manner, you can actually show the value of your solution to all sorts of publics. And actually, many of them can actually run this workflow and get results. So you don't need to be a data science expert, alone there working on this. It's a collaborative effort. So what you see here, as I said, we start with the image, high resolution image. This is an area of about 100 square kilometers. It's a very big area in Houston, Texas. We're not going to disclose exactly where, but this area here is what we're going to analyze. So as you can see here, we're already using one tool which takes in the image path and displays it to us. So we can take a preview of this image. It's a very high resolution image, but here we're just looking at a preview of it. Once we have that, our second step is actually to collect image metadata, extract image metadata from this image. So it's one thing for you to have the image. The other thing is for you to have its geo coordinates and metadata about it. What is metadata? Metadata is information about the image. So we're talking about the shadow, the angle, the cloud coverage, everything related to that image, when it was taken, and all that information is important for our analysis. So what you see here, where my mouse is a macro, and a macro is just a tool that we created, and it's a tool that actually is composed of many tools in the background. So if I expand this tool, I'm going to show you guys up here. What you see here is that it's actually many tools that composes that. It's a multi-part function. So you have your input or multiple inputs, and you have one output or multiple outputs. In this case, it's a mix and match of many tools such as regexes, filters, select tools, summarizes, joins, transpose, and then you have your very specific geospatial tools here, which is highly important to us since you're working with satellite imagery and geospatial coordinates, locations, and so on. So you have some points here. You have a tool that puts your geo coordinates together to create a shape. So I just wanted to show you and highlight how one macro is actually multiple tools in the background. So that's a very cool function for us. And even the item we actually customize. So you see that the items tell a story, right? So you start here, it's an image and the metadata attachment to it. So that's our macro. Okay, so what is the output of that macro? Let's take a look. Once you click there, we're able to see that one of the information we're gathering from that image is the location. So we have the bounding box around that actually composes that contour of that image, right? And that's very important because, again, if you have an area of interest, you can target and then make sure that only the analysis is only running inside of your target. So here we have our area of interest. And again, this can be any shape, right? Right now we're showing this box to make it easy for us to see on the demo, but it could be any shape, regular or irregular. So here it is, our metadata on the image. So now we've gotten two inputs already. One that's the full image. The second one is a little bit more structured in terms of it's a geospatial, so we actually have the coordinates that make up that bounding box around the image. Let me check the Q&A here, make sure. Are these workflow accessible in the application help as tutorials? Yes, I am pretty sure all of these tools and workflows, they can have examples once you click on them, and it'll show you how to run each one of them and many examples from it. So now that we have our metadata of the image, what we'd like to do is find each property inside of here, inside of that area of interest. And how do we do that? Well, that's where we have our proprietary data set from review. And we have some secret sauce in there. But essentially, we're targeting and finding each property of interest and what is the boundary of that property. So what you see here is just a sample, a 5% sample of the properties of that county. And it's very dense information, as you can see. And I'm only showing 5%, but in reality, we actually have about, let's see here, 1.5 million records, just right here, just from this one area that I highlighted on the box. So 1.5 million property boundaries, and we are able to import it, as I said. Here, I'm just showing a little bit of it for speed of this demo. And this property boundary data is important for us because our goal is to crop each property image and then classify it. So this property boundary is an area of interest for us to have. So Okay, once we have a location of all the properties around that county, right? Notice that right now it's not filtered into the area of interest, to that box. So how do we do that? How can we match the metadata from the image, which is a bounding box, and then all the possible locations and properties? Well, again, we're leveraging another spatial tool from Alteryx. It's called spatial match. So this image, this tool actually takes in a area of interest or any shape or two shapes or multiple shapes, and it gives you a combination. So you can actually select intersection or only the shapes that are within a certain area or outside a certain area and export that. So why that is interesting for us again is that we're combining unstructured data and structured data, and especially spatial data. You guys know spatial data, geospatial data. You have different formats geographically and standards, and sometimes for you to get, not sometimes, but for you to get your accurate results, you really need to make sure that they're stacking, on top of each other correctly, and that you're not leaving anything behind. So here's the output of the spatial match data tool. And what you have here, as if you guys remember, we started with the image. From the image, we collect this overall box, which is our area of interest shape, the square here. And then we overlaid that with the property boundaries data, which was all over the county, but now we only filtered for the properties that are inside of our area of interest. So it's a filter, right? It's a geospatial shape filter. So now, as you can see, there are more properties all around here, but we're only focusing on these here because it's our area of interest. Now, this square here, or this box, could be your county, could be your city, your neighborhood, your state, or any shape you have, right? So that's why we're choosing an area of interest and we're running this analysis only inside of it. Nice. So what else we have to do in order to get our results? Well, once you have your selection here in the middle, each of these dots, the blue dots you see there, are the properties. So we have about 62,000 properties, property boundaries, not just properties, but property boundaries. So they're shapes. Each of these blue dots are shapes. And we'd like to take those shapes and actually see each one of them as an image, a cropped image. So the model can classify it, right? That's our goal, where we're heading towards. Okay, but before we get there, we have to remember that these shapes here, they can come in very different formats. So they can be very regular or irregular shapes. You can have your nicely square, such as we have here, this big one, or you can have, just imagine all types of property lands that people have, right? Not all of them are in nice grids. Some property lands and property boundaries are very weird shapes, and we take all of them and we normalize it using this macro here where my mouse is. So again, this is a macro we constructed. It's a tool with many tools in the background with input and output. And all this, the result 62,000 properties that are inside of this box, I passed to this tool and we normalize those shapes, okay? Those shapes normalize, we then convert the shapes coordinates or latitudes and longitudes to pixel positions related to the image, to the original image. So now, again, we're mixing and matching data structures here, right? We're translating the shapes, which are coordinates, geo coordinates, into pixel positions, more like X and Y. So we're translating that into pixel positions so we can identify where in the image those properties are, right? So all the way down here, we're getting the property, we're creating the shapes of those properties, normalizing them, filtering. Now we want to see exactly in the image what areas in the image relate to each one of the properties that we see here in these shapes. So once we do that, once we have the actual coordinates of each of those, the coordinates and the pixel positions of these properties, again, you have to think of this as the original image, right? So if I go back here, I wanted to have this image in your head. Now I'm going to go back to the image here, the full image, and you remember, right? That's actually what it looks like. And we're overlaying the shapes of each of these tiny properties, overlaying that with this image, and now we're going to crop it. So I'm going to go here, zoom in into our, we'll go into a little bit on the analysis now, right? Everything down here has been collection and pre-processing, and now we're going to go into cropping. Okay, so now we have a tool here, another macro that we created by leveraging Alteryx tools. And again, a macro is a group of tools that work in the background. So if I expanded this macro, the image cropping one, you'd see that it's a mix and match of tools. And actually, one of them is really interesting because it's a Python tool. So we love Python, and we love the fact that we can mix Python outputs or R outputs and inputs with Alteryx. I think is just such a good use of this because it allows us, again, to bring in very advanced models or scripts that we already had, or that you'd rather code it in Python first before you bring it to Alteryx for POCs or for prototypes. And you can then bring in. So here we're using some proprietary libraries in Python that if I clicked here, you'd see the Python script right on my screen, and you'll be able to code it there. Or you can import it and then use it as you wish. And actually uses a Jupyter notebook layout or interface for you to program this. So very, very useful for us that we can bring that Python integration. And once you go back to our overall workflow, it just looks like another tool from Alteryx. So you wrap it up with a wrapper, right? So you can call it and link it with many inputs and outputs. So, okay, what is the output of this? So again, I'm just going to select a sample of these images that we've cropped so you guys can see on the left side here. And you can see some of the results. So each row here, it's a different property, right? Think of each row as a different location on that image or a different address. And here we have the property boundary and the image related to it. So as I scroll down here, you see the different images that are literally just cropped to each property boundary. And as you see, because we're looking at different time frames, some of them have construction, some of them are already built, some of them are just land. So a mix and match of types of properties there in construction activity. I'll show you more examples down here. And this is where you can see the effect of that high resolution image, right? This is 50 centimeter resolution. So you're able to see many details, such as pools, trees, or details of your property there that obviously we're not using for any malicious use. And actually we have a lot of titled certifications and titled procedures because of the census. And essentially, when we mask all of these, we're just caring about the construction stage. So that's the level that we work on, right? We abstract all of these details and we're just considering the construction stage that's going on. So what is our goal again? Our goal is to classify construction stage on a certain area. And to do it, you have to classify the construction on each property. And to do it, you need to analyze each image of each property. So here we have each image of each property. Now, what we do with this is we give each image that you see here. So each image here is one date, right? It's a certain time frame and that image for that location. So if we give these images to the model, and what is this model, right, that we talked about? Well, this model that you see this here, this icon, is a machine learning model. It's a deep learning model that classifies images. And the way it does that is not by magic, as it would be really cool if it were, but we trained a machine learning model with thousands of images to actually learn what these images refer to. And then once it learns, you can give it any image similar to that situation or similar to what you've trained it on, and it will tell you what is the classification of that image, what is the construction stage in this case. So when you see some of these results, what you see here are the outputs of the model. So we're calling our model, which is running on a separate server, and actually it's an API call, and it gives us back the results very fast because we've already trained the model. So you can just call, get the classifications, and get the results back. And essentially what you see here on the left side on our browse or report tool is each row. If you go from left to right, follow my mouse here, each row is a location, okay? It's an address. And we track that address or the image of that address over time. So for each row, it's one property, one address location, and we're going month by month. So month 1, month 2, month 3, month 4. So as I go through here, please identify yourself here in terms of, left to right and making sure that each row is a property. Okay, so first property, we're looking here, of course, everything is masked, so not to disclose any information. What you see here is the model's classification. So these labels you see here on the bottom are actually automatic, computed by the model by looking at the image and telling us what the classification it is, what construction stage that is in, based on what it's trained on. So with every model, as you guys know, no model is perfect, and you see good classifications and some false positives, maybe some false negatives. But the most important thing is for you to have a way to improve your model over time. And what you see on these models we have is that they're already very good in terms of classifications. And over time, not only we classify the images that we're constantly tasking monthly, but we use those images for retraining so we can improve the model. Okay, so I just want to give a background on the modeling part and just to go over some of these results. Again, you have this property here throughout this 4 months, right? Over time, you see that nothing happened on that image. Nothing happened on that location. So what you see here is that the model is classifying this completion across. So that's something that is correct, right? You see the completion, and it is completion across all those 4 months. If you scroll down and you see some other locations, let's see the record 2, it's a different property. Over time, you can see that it actually they built something there, and you can see how the images were changing over time. And if I were to zoom in, you actually can see the roof and some of the angles that compose the roof, and even a driveway down here. So again, if you look at what the model classified these images as, it classified them as a start in the beginning, this one, the first month, and then completion, completion, completion. So those are labels that automatically came from the model. And that's the automated part where as soon as we notice a start, we report that for census and keep tracking that location over time until it's a completion. And of course, you can do revisions, month by month. And when you aggregate that, the whole progression, that is also very meaningful for us to know, to learn about how long construction activity lasts on average and all those stats that you can have from this. So as I keep scrolling down, you see more examples here where you start, you have a construction start and then the model classified it correctly. And then sometimes you have what we call pre-construction, depending on the layout of that land. But it goes, as you follow it over time, you get to a completion. And you can see the roof there. Every construction also is very different, right? Constructions are completely different from each other because people are not same. So they build on different time frames. Some constructions last more, some constructions less. And they take different shapes of roofs, different formats of the land. Some have more trees, some have less trees. So this is a model in progress and we're learning with it. Of course, also we have some workarounds when you have properties that are completely covered by trees, for example, right? If you are asking yourself, oh, how about cloud coverage? How about treetops? Well, yes, this is one of the alternatives that we have to think in terms of satellite image, right? We classify that property from above. So the image has to be clear. And we can get that by tasking it constantly. We can get it, if the satellite has gone already, we can try it on the second pass, the third pass. And then in the case where you have treetops, that's when we have to use a different type of model to get this classification. And I'm not going to go into there, but there's machine learning for this use case as well. As I keep scrolling down here, I'll show you guys more examples where you start, you have a construction start or pre-construction, and then at some point, this construction is considered complete, and then you have the completion. Again, here's a good example, right, where you have your start, a very clear construction start, then it becomes a completion, but then the model classified as a pre-construction again, which kind of doesn't make sense because, if it was already completed, you wanted to go to in state completion. So this is to prove you guys that, the model is still under progress, but on the overall classifications, I'm only showing here 13. But we are tracking on that 98% accuracy, actually, if you looked at all the 60,000 or 70,000 properties that we're analyzing. So it's a very good accuracy. And the fact that you have a little bit of a misclassification here is not a affecting factor for us, especially because we consider the progression as a whole. So as it follows along on a time frame, we can correct and change these classifications as it goes. So let me keep going down here. So you have another one that's a very clear foundation here, the concrete, and then becomes a start based on the classifications and completions. And again, you can see the roof, the driveway, some factors there that the model uses for this classification. Same thing here, pre-construction, completion. Same thing down the bottom here. We've got a start, then your completion. You can see the roof lines. Go to the right over here, show a little bit more of these classifications. Some of the locations, of course, might not have any constructions or not even a building. So you can see here on this record 11, this property, over time, nothing was built, right? Or maybe they just didn't start that project. So you don't see that structure in there. And the model didn't classify a completion here because you don't see that structure. There's no house built here. Opposing, right, to this one on record 12, this property actually was already built. And you have the property here month by month, not changing. So they're all completions. And then this last one here, you go from pre-construction to a start, and then it stays a start because they didn't finish this build yet. Maybe on the next months they will. So these are examples of these properties and the images that we crop and classify, and what is the classification the model gives us back to us. And what we can do with this is, again, use more spatial tools and more tools from Alteryx or proprietary tools you might already have, mix all of them up, and then create a report. So from some of these classifications I showed you guys, what we can do is map them back. So what you can do is, and this is masked by the way, so these are not actually accurately to what the locations they're pinned in, but it's a representation of what it would be. So this is synthetic in terms of addresses, but you can see the power, right? Where you can track a construction by its location and what is happening on each location. So here you have the initials of the classifications. Remember, P is for pre-construction, S for start, and C for completions. And you have the classification progressions together. So you can actually look back in time, I guess, some history of that project and the latest classification that you have for that location. And you can see where that is in the map. So with this here, what you can do is you can aggregate everything up to, and say, okay, we have X amount of starts in this county or that county or this state or a federal level. So you can aggregate, and with this, we have more workflows that we use from Alteryx to do that and report specifically to what Census wants in terms of their format. And we can't show that here, but you can think of similar tools where we actually aggregate and label the data to send to Census on a final format. So I'll just zoom out from this workflow again, so you can see how, we start all the way over there with your location and date, and then you have an image of the whole location, right? Houston, Texas area of 100 square kilometers. And with that, you take the metadata, we get the property boundaries down here, we pre-process the image, crop them, analyze with the model, a machine learning model called by API, get the results back, aggregate, map, and report. And we do all of this every month automatically with the scheduling mechanism, and actually Alteryx has a scheduler on the server. So that's the level of automation we're bringing here, guys. We are helping Census with this tool tremendously because, we just had an example here with COVID, as people couldn't go outside and do surveys face-to-face. They couldn't, right? That's a physical barrier. So that's one example of why a solution such as this one is interesting, where you can automate the process from the satellite and get the images and apply machine learning and get your results. So this brings you exactly down to the ground truth of what's going on down here, right? There's no way around this. There's no way around of faking this data, right? And once you have it, you're down to that ground truth. This is the veracity of this data. And so this helps, Census, of course, bring another level of integrity to the data, to the construction indicators they're providing. So you can compare this whole automation, this whole solution that is scalable. It has integrity to it. It's fast to process. So on our classifications, I forgot to mention, but you can actually classify once you optimize for GPU and parallelize the servers. You can actually classify about 1 million images on around 1 hour. So that's very powerful. When you can classify that many images, you're able to cover the whole country and multiple times even, so you can verify and make sure that everything that you're running there is correct. So I think that's a wrap, Andrew. We can probably, I'll turn it back to you so we can answer some questions.